All right, we got one more section to cover before these videos are all caught up. If you've been waiting on these, I apologize. But here's the last one, and then all of them up to this point should be up. So 10.2 is using combinations. So combinations are similar to permutations. Permutations, remember I said in the last section, the order mattered. These things had to be in a specific order. Combinations are different. They don't have to be in a specific order. Okay, so A, B, C, C, B, A, they're the exact same because they have the same letters. Okay, so you can't tell them apart that way. So the formula is slightly different. So it's NCR. N is still your total. Okay, so remember we said that last time. N is still your total. R is how many are being used. Okay, but again, the order is not important. So it's NCR is n factorial over n minus r factorial. That's all the same. This is the new part from the permutation. I've got that extra r factorial down there. Okay, so there we go. That's the difference. So for this first example, it says 15C7. So 15 is your n, 7 is your r. So to solve this, I would go 15 factorial over 15 minus 7 factorial, 7 factorial. Now I can keep working this out. You get 15 factorial, that's 8 factorial, 7 factorial. From here you can expand that out or use your NCR button. It's the same place as the NPR in your math menu under PBR, and that works out to be 6,435, and there's your final answer. So that's how this NCR idea works. Okay. Now we can put that into use some of the same ways that we did before. So I've got 5 cards in a deck or in a hand in a card game, whatever the game is, but I have the 52 total. Okay, I want to know how many ways those 5 cards can come out. So my total would be 52, and my number I'm being used is 5. So it would be 52C5. Okay, so setting up this formula, 52 factorial over 52 minus 5, or 47 factorial, and then 5 factorial. Okay, so I take that, plug it through the calculator, and I end up with this, 2,598,960 different possible ways these cards could come out. Okay, so that's how the NCR works. The toughest part is making sure you can recognize if order does or doesn't matter, and then what is your N, what is your R. Now the next question, same idea. We got 5 cards of 52. How many of them are the same color? Now here's what we got to think. In any deck of cards, I've got 2 colors. I've got black and I've got red. Now in black there's 26. In red there are 26. So I've split those 2 things apart. Okay, so I want to start with my black ones. I need 5 cards that are black. Well, I've got 26 to choose from, and I'm choosing 5. Then I'm going to add my reds. Now, in red, I've got 26 cards to choose from, and I'm choosing 5. So I go 26 C5, and I get 65,780. Now, of course, the other one is going to be the exact same. Okay, so for the black one, I have this amount. For the red one, I have the exact same amount. So when I add those 2 things together, I get 131,560. That's how many of those 5 card hands are the same color. So referring back up to what we did above, there are just about 2.6 million 5 card hands. Only 131,000 have the same colors. So that's, you know, just a fraction of what's out there. All right, so let's keep moving on. Now this question is very similar. So I have 10 books, 5 are nonfiction, 5 are fiction. I need 4 books from that set. So you ask yourself, what's the total? Well, the total is 10. Okay, that's your N. How many of these books am I choosing? Now there's a couple numbers in there that you don't need. The 5 nonfiction, the 5 fiction, that doesn't tell us much. That's just my 10 books. I'm choosing 4 of them. Okay, so I would use 10C4. Now again, go back through, put that in your calculator. You end up with 210 possible books, combinations, and there you go. Now, how many ways are those books all fiction or non-fiction? Now this is where, like last part, we've got to figure some things out. Now, I have 5 fiction, I have 5 non-fiction. I want just fiction. Well, I have 5 books, I can choose 4 of them because I'm still wanting 4 books. Okay, the next one, I have 5 nonfiction, and I'm choosing 4 of them. Okay, so this is what we've got as far as what they're looking for in this problem. Now I go back, try and work these out. So 5C4 is 5. The other 5C4 is 5. 5 plus 5 is 10. And there you go. Now there's a key word that shows up in that question as well. Well, this one doesn't read it, but if I put black or red, the key word there is or. If I look down at this next one, the key word there is or. In math, especially probability, or means add. Okay, so we're going to be looking at that. And means multiply. So I want to pay attention to those words. All right, final one here. A student senate has 6 seniors, 5 juniors, 4 sophomores, 3 freshmen. How many different committees of 2 seniors and 2 juniors can be chosen? So we're going to start with our seniors. Okay, I need to know how many am I choosing from? What's my total? Well, I have 6 seniors, so my total is 6. And I am choosing 2 of them. Then I move on to the juniors. The juniors has 5. Okay, put that a little bigger. There we go. So I've got 5, and I'm choosing 2 of them. Now the key word here is and. And means I'm going to multiply those 2 things together. So I go to my calculator, I type in 6C2, and I get 15. I then go 5C2, and I get 10. So there's 15 ways to choose 2 seniors. There's 10 ways to choose 2 juniors. Multiply those together. You've got 150 total ways that you can choose those representatives. And there's your final answer. All right. So that's 10-2. Make sure you get the assignment done. You can find it on the portal. Look on your page, see what you're missing. If you have questions, come and see me.